Hello everyone, my name is Mugilan Ganesan and I'm a 10th grader who loves to code. So I'm fully self-taught and I've learned languages such as Python and JavaScript in my free time over the past year. In my school's computer science classes, we use a made-up language called pseudocode. We also have to draw flowcharts of our pseudocode programs in our notebooks. So since drawing a flowchart is extremely tedious and a bit of work, I decided to automate this by creating a converter which generates flowcharts from pseudocode. Now, this converter is around 700 lines of Python and it can be used as a CLI tool. So it's fairly complex, but to summarize the philosophy behind how it works, it represents flowcharts similarly to binary trees, and it goes line by line, where it profiles each pseudocode line as blocks with coordinates on the tree's branches. If you want to know more about exactly about how it works, you can go through the source code, which will be in the description. You can just follow the GitHub link to the repository. So I'll give a few demos of how exactly this works. So we'll start off with this text file. It is called example1.txt. Right. So now that we're in the directory, we can run the code straight from that directory. So I'll just set it up here. So now this text file is extremely simple. This pseudocode merely just takes two numbers and it just sums up the numbers and then it prints out the sum with a few prompts for user input and whatnot. Right. So we can just input this command line tool and it will generate a flowchart. These are the image dimensions. Now, this flowchart will be in flowchart.png, and as we see, it enters a number, it inputs that number, right? Enters a second number, and it sums it and it outputs it. It has start, stop, it has the arrows, it's got everything, and the image is well shaped to make sure that it's all symmetrical and that there is no issue with the sizing of any of the blocks or any like overlapping lines or whatnot, right? And just for a bit of context, these rectangular blocks are process blocks, whereas these parallelograms are used for input-output. So the pseudocode compiler, the generator, it actually, not only does it profile the coordinates of the blocks and stuff, but it can actually understand what type of block, like what type of shape each of these lines falls into. So it'll take output statements and, throw it into a parallelogram. Okay, so this is very basic. You can see there's just one flow direction. So we can try a more complex example. We'll take example 2. So what this one does is the user inputs a number and it'll just output whether that number is even or odd. It's fairly simple. So we can take example 2 as our input and it generates an image, right? And now this thing actually has an if statement in it. So you'll be wondering, how does it actually handle if statements? How can it handle branching? And voila, it actually handles it. So you can see it's perfectly symmetrical and all the arrows are drawn. It even shows the yes and no branches just for like preventing confusion. Arrows everywhere. It's well symmetrical. No overlaps or anything. They join up together. It's very clean, as you can see. So that's great. It can handle if statements and branching. But that's pretty simple, right? You're like, okay, it's just one if statement. So let's take a more complex example. Okay, fine. So what I did here is I just copy pasted an if statement inside an if statement just over and over again. I don't know what I was thinking. But the point of this example 3 is to show that I can handle nested ifs. So as we can see here, inside the first if statement, there's another if statement. And then within the second if statement, there's a third if statement in the else. So we have 3 nested ifs actually. So we can run it on example 3, it generates a flowchart. And if we view it, we find that inside the if statement there's a second one, and inside the second one there's a third one. All the directions are done, it's symmetrical, looks clean, even the image is sized accordingly, it's very well done. So that's pretty simple, alright. You're like, okay, we can do nested ifs, that's great. Now we can even try it with loops. So in this one, you just loop through a number. You just loop through numbers 0 to 10 and output whether that number is even or odd. It's simple, but it uses while and if. So now we can test our compiler here. We run the code, and there we go. So you can see while can be represented entirely in the form of an if statement where the line goes backwards into the if. So it'll perform this thing where it'll output the value of n, get like increment it, and then show whether it's even or odd. It'll loop back here, and then it'll just keep repeating like this. It's very nice. And if it exits the loop, then it'll go like this and no. The arrows are all shaped. It's very clean. It can handle nested loops or nested ifs or anything. So now what I want to show is this. If we go over here, this thing can actually be used as a backend, not just for pseudocode, but it can be used as a backend to generate flowcharts for almost like any language which can be turned into pseudocode. So what I mean by this is this. So there's an online tool which I found on GitHub, which essentially takes Python code and converts it into pseudocode, the same pseudocode standard our own school uses. And what this means is that you can use this as like a front end to convert Python to pseudocode, and then take this pseudocode and turn it into a flowchart, which effectively makes it Python to flowchart. Right. So, for example, I can run this guy's code, and it'll generate something, right? And this is what it's generated. So, we can take this, and we can run it through the compiler, and we get a flowchart. It's taken Python code and it's turned it into a flowchart. Very impressive, right? And if you want a more complex example, I've written some pseudocode to actually like draw diamonds and stuff. This is actually Python code and it works. You know, it actually works pretty well. And you can just run it on something like this. Right, it's got a while loop, it's got like a for statement inside the while loop, and then it has an if statement with another for statement inside. But the flowchart converter can handle it. You can see this. It has a while loop, it auto creates the for loops and everything. Everything lines up, it's symmetrical, it's great. And it just works very well. Right, so I think this is enough demos to show that it can basically do anything. Like you can use nested loops, nested ifs, and just do just about anything you want. And you can even change the sizes of stuff. So suppose I'll take this file that we've just converted, example 6. I can specify size, like, oh, it's too big. I'll set the size to like 10. Now you can compare these two, and the sizes are halved. It'll generate smaller flowcharts. So the sizes are completely adjustable as well. It's all up to user input. If I change it to 3, it'll generate a much smaller one. If I set it to like 20, it'll generate a much more high resolution one. And with 40, it'll generate one which cannot be shown because my IDE can't show it. But like, it'll work basically, right? So that's it, yeah. And now, the issue is there's still a few issues with this. One issue is that, like for example, I want to integrate else if statements, and I also want to integrate like off-page, on-page connectors, right? So it's still missing a few things, but this is enough to make it complete. It's where you can like practically represent any program, right? Instead of else if, just use nested if. And also, what I think is that instead of just keeping this for pseudocode, we could instead link this up to LLVM's intermediate representation language, and therefore allow any LLVM compiler, any LLVM compiled language, right? Any LLVM front end, like take Clang, right? Or Clang, and take Rubinium or Rubinius. All of these things will convert languages like Ruby and C to IR, intermediate representation. And if you can take this IR and then use this program to convert IR into flowcharts, you effectively have like a backend which can be linked up to multiple different languages to produce flowcharts for multiple different languages. It's very flexible in that way. So it's also therefore very expandable. It has lots of opportunities. Yeah. That's pretty much it. Okay, that's my project. So if you want to check out the source code, then you can look below and you can check out the description to see the GitHub repository, read up on the source code, and I also have a README with documentation and more details. So yeah, that's it. Goodbye.